in that last segment, I was talking about the postganglionic neurons in the parasympathetic division and how they're relatively short, which is the opposite of the sympathetic division where they are relatively longer. So parasympathetic activation and their neurotransmitters. The preganglionic neurons tend to be long, and the postganglionic neurons are short, and they release acetylcholine, just like with the somatic nervous system motor neurons. So this figure shows both sympathetic and parasympathetic division neurons, preganglionic neurons. They originate in the central nervous system. Preganglionic fibers are short in the sympathetic division compared to longer in the parasympathetic division. The ganglia tend to be much closer to the central nervous system in sympathetic, further away in the parasympathetic, actually sometimes within the target organs. And then the neurotransmitter release in sympathetic division is either, as you see here, red and or green color-coded, norepinephrine or epinephrine, also called noradrenaline or adrenaline. And then sympathetic division, it is always postganglionic neurons are always releasing acetylcholine, just like with the somatic nervous system. Oh, here we go. So another view. All right, somatic nervous system. Neurotransmitter released is always acetylcholine, just like with the parasympathetic division, as we see here. And similar in the sense the sympathetic, parasympathetic division and the somatic nervous system. Preganglionic neurons, their fibers tend to be long and myelinated. Right? The motor neurons of the somatic nervous system, long fibers, myelinated, release of acetylcholine. Also in the parasympathetic division, release of acetylcholine. With the sympathetic division, preganglionic neuron fibers short, myelinated, postganglionic neuron fibers long, unmyelinated. Postganglionic neurotransmitter release is norepinephrine or epinephrine to hit the target organs. And the reason that sympathetic division and parasympathetic division have opposing effects on the target organs. So for example, sympathetic division will increase heart rate, parasympathetic division will decrease heart rate. The reason being is because the chemical signal that the target organ receives from the different divisions are different chemicals, different neurotransmitters, which will cause opposing different effects on the target organs. So overall general functions of the parasympathetic division, its activation, constriction of the pupils, secretion of digestive glands, materials for essentially digestion, right? Salivary glands when you start eating or you think about starting to eat, and gastric digestive gland secretion to help break down and digest your meal. Increase smooth muscle activity of the digestive tract, again to deal with food digestion. Decrease heart rate. Sexual arousal in both sexes, male and female. Overall, a rest and digest system, with these effects essentially being the opposite of the sympathetic division activation. Okay? So relationship between the two divisions. Most of our organs are innervated by both sympathetic and parasympathetic division, so you have dual innervation. Typically, sympathetic division increases activity of the organs. In general, parasympathetic division slows down or stops activity of its target organs, and they have antagonistic effects. And again, because the target organs receive different neurotransmitters So they have different effects on the target organs. And that's it for this chapter, relatively short and simplified.